All right, so for our last objective of this unit, we are going to talk about graphs of functions. So let's go ahead and review right now. So in each of the following, we want to state the domain and the range and then decide if it's a function or not. And we are going to explain using words such as input, output, domain, and range. All right, so go ahead and try these two review exercises on your own. Go ahead and pause the video and do that. Okay, so hopefully you paused the video and tried some of these on your own. That's the only way you're going to get this practice in, is by trying them on your own. So make sure you're actually pausing the video. So looking at A, if I want to find the domain, right, the domain, remember, is going to be your x values. So the domain is looking from left to right. So if I look at this domain, it's starting at -5, and it's ending at 4, looking at that graph there. So it's from left to right, starting at -5, ending at 4, so my domain would be -5 to 4. My range, remember, is looking from the lowest point to the highest point, so up and down. So I'm looking from the lowest point is -5, my highest point is +5, so my range would be from -5 to 5. And then is this a function, yes or no? So for this one, yes, it is a function because all inputs have one output. Another way to do this, remember this is a graph, this passes the vertical line test. If I drew a vertical line anywhere through this graph, it is going to only pass through the graph once, so this is a function. Looking at B, B should be a lot easier, right? I already give you the numbers for the domain and range, so you just have to list them out. My domain, remember, is your x values. So these are all the x values. And then my range is my y values here. So my domain would be -4, 0, and 6, and my range would be 12, 18, and 40. For this one, it is not a function. The reason why is because this 6, this input of 6 has two different outputs. So for that one, that is not a function. All right, so hopefully that was just a bit of review on domain and range. For this lesson, we are going to be focusing mostly on graphs of functions, analyzing some different parts, and increasing and decreasing intervals. So let's start with our first example here. We're going to analyze some different features of the graph. So graphs are one of the most powerful ways of visualizing a function's role because you can quickly read the outputs and the inputs. You can also easily see the features like a maximum or minimum. And so we're going to review that right now, this maximum and minimum. Before we do that, let's review. We've done this quite a bit this unit. We want to first find f of 4. Remember, this is our x value. Okay, so if I want to find f of 4, I'm going to go to 1, 2, 3, 4 on the graph, that's my x value, and go up to where it meets the graph. If I look at what my y value is here, that is going to be at 1. So f of 4 would equal 1. For my next one, I want to look at f of -1. So I want to look at where x is -1, go up to my graph, see where it matches, and see what my y value is there. So if I count up 1, 2, 3, 4, 5, 6, f of -1 would be 6. All right, so for these, remember you're looking at your x value and seeing what y value it gives you. For B, it says for what value of x does f of x equal -2? So let me go ahead and erase this so I have a clear graph right here. I want to look at for what value of x does f of x equal -2? That means that -2 is my y value. So I want to look at my y value of -2. So I'm going to draw a line there. That's right here. So that actually happens twice. It happens right here. It also happens right here. That's kind of where it crosses through the graph. So the first thing I did, I looked for where is y equal to -2. That's that whole part right there. And so that's going to be at x equals 1. That's one of them. Another one is at x equals 3. So it happens twice here. For that one, I'm kind of working backwards. Now, something new that we're going to talk about today is our minimum and maximum values. And that's exactly what it sounds like. The minimum is going to be the lowest value, and the maximum is going to be the highest value on the graph. Think of minimums and maximums as your part of your range, right? We want to look up and down to find that. Our minimum is going to be the lowest value, the lowest y value, and the maximum is going to be the highest y value. So let's start with our minimum. Let's look at our graph. The minimum is going to be right here, where the graph is the lowest, right? So our minimum is going to be at y equals -3. Our maximum is going to be our highest value. So our maximum would be right here and right here. Those are at the same y value. That's the highest value I see on this graph. So that's at 1, 2, 3, 4, 5, 6. So y equals 6 would be my maximum. So again, the minimum is the lowest y value. The maximum is going to be the highest. So that's something new we're talking about today. All right. So go ahead and pause that video, and we're going to try the your turn right here. So you're going to try number 1, A through E, on your own. All right, pause the video, try that out, and then we'll go through some of these answers together. All right, so for part A, you should see those answers. Go ahead and check those out. I also labeled the graph too to help myself out a little bit with the numbers, so I didn't have to count every time. So f of -7, I went to -7 on the graph, and I saw that was at -6 for my y value. F of 4 is equal to 1. F of 0 is equal to 3, and f of 9 is equal to -4. So go ahead and check those and see if you did those correctly. For part B, I kind of labeled that on the graph as well. We're going backwards now. It says, for how many values of x does f of x equal 5? So I'm looking at my y value of 5, and I drew a line through that. And so I saw it pass through the graph 3 times, right? 3 times. So 3 values of x. Part C, what is the y-intercept of this relation? We haven't talked about this yet, but y-intercept is just where it crosses the y-axis. So our y-intercept would be at y equals 3. And then it says to state the minimum and maximum values of the graph. So I'm going to erase this so we can look. All right, so our maximum value is going to be the highest point on our graph. So hopefully you notice this is our highest point on our graph, right? The maximum is going to be the highest y value. So where is that at? That's at y equals 6. The minimum value is the lowest value on the graph. So hopefully you notice that lowest value is going to be right down here, and that's at y equals -6. So the maximum is the highest y value. The minimum is going to be the lowest y value. All right. So last but not least, explain why the graph above represents a function. And remember, we can do that by using that vertical line test. So if I draw a vertical line anywhere through the graph, it should only pass through once, right? So this is a function because it passes the vertical line test. All right, so make sure you have that written down, and then we're going to move on to the last thing we're going to talk about, which is increasing and decreasing intervals. All right, so I think of it increasing and decreasing intervals. Whenever I read a graph, I always read a graph from left to right, and that's super important when you look at increasing and decreasing intervals. So for example 2, it says the function y equals f of x is shown graphed below over the interval of -7 to 7, right? That's my domain. It's starting at -7 and it's ending at 7. So the first thing I'm actually going to do is I am going to take a second and I'm going to label this graph with my x values and y values to make my life a little bit easier. So maybe you pause the video right now and do that on your own. Alright, so if you did that on your own, that's just going to make your life, like I said, a little bit easier and this a little bit easier to read. So it says, would you characterize the function as increasing or decreasing on the domain of -5 to -1? So remember, your domain is going to be your x values. So -5 is going to be right here. So this is where we're starting. To -1, that's where we're ending. Okay? So looking at this graph, looking at it here, from -5 to -1, is that going up or is that going down? Is that increasing or decreasing? And I always read a graph from left to right. So from left to right, that's pretty obvious, right? That is increasing. Right? And the reason why is because that graph is going up. Think of a roller coaster, kind of. It's increasing from left to right. Right? So make sure you explain your choice there. I kind of explained it verbally. Make sure you explain it in writing. I will be checking for that. For part B, it says give one additional interval over which the function is increasing and give one over which it is decreasing. So let's start with increasing. So I should see on the graph, it's also increasing right here, going up right here. So that's going to start at 2, and it's going to end the increasing at 5. So how I'd write this is very similar to how I'd write a domain. So the interval from 2 to 5, and I'm just going to put that x in the middle because I am describing the domain where it's starting and ending. So whenever I describe increasing and decreasing intervals, I'm always going to use the x values to describe that. All right, let's look at a decreasing interval. So I'm going to pause this for a second and erase some of this so we can look at a decreasing interval. All right, so a decreasing interval would be going down from left to right. So there's quite a few of those. So let's point out a couple and then we're just going to pick one. So you should see right here, this is decreasing. So this is decreasing right there. Right here, this is also going to be decreasing. And this is also decreasing right here. So those three intervals are decreasing. So we just need to pick one of those. Let's do this middle one. Doesn't matter which one you pick. Okay, so it's going to start that decrease at -1. Again, I'm looking at my x values. And it's ending the decrease at 2. So it's decreasing all the way here, from -1 to 2. So that's a little bit of an intro on increasing and decreasing intervals. All right, so I want you to go ahead and do that your turn right now on your own. So answer those questions, give an increasing and decreasing interval, and then explain if the function is increasing or decreasing over the interval of -1 to 1. Pause the video and do this on your own. Number 1, we're doing on our own. All right, so hopefully you notice I did label the graph to make my life easier with those numbers. And I did point out also that first increasing interval, yours might have been different. You might have used this interval here or this interval here, right? Those are all increasing because they're going up from left to right. I picked the one in the middle. So the one in the middle, it's starting at -3 and it's ending at 1 here. So it's increasing all the way from -3 to 1. If I want to find a decreasing interval, we have 2 of them. So let's just do the first one here. So this one is starting to decrease at -6. It's kind of where it reaches the peak. and then it's ending its decrease at -3. So I always want to go from the start to the end. All right, the last one, part B, is the function increasing or decreasing over the interval of -1 to 1. So I'm going to erase some of this so we can look. All right, from -1 to 1. So let's look there. So -1 is right here. 1 is right here. So it's asking, is this guy increasing or decreasing from the interval of -1 to 1? So that is pretty obvious. That is increasing there because it is going up from left to right. All right. The last one I want to do is number 2, and I'm actually going to do this one with you because there is a new term here. So this one says, give the intervals where the function is increasing, decreasing, and constant. So the one word I want to go over with you is this word constant. And that word means, right, it's neither increasing nor decreasing. So I'll give you an example of that, where it's neither increasing nor decreasing. It's kind of like a steady pace. So that would be right here. Hopefully you can see that on the graph. So if I want to write an interval where it's constant, I could say that would be from -3 to -1, right? Because that's where it's neither increasing nor decreasing. So it starts the constant at -3 and it ends at -1. So what I want you to do right now on your own is I want you to write an interval where it's increasing, decreasing, and then the other interval where it is constant. There's one more interval where it is constant. Pause the video right now and do this on your own. All right, so I wrote in those intervals, it's increasing. Hopefully you see it's increasing from -5 to -3. And then that's where it starts being constant from -3 to -1. And then it starts decreasing from -1 all the way to 2. And then lastly, it's constant again from 2 to 4. All right, so check those intervals out. Make sure your work looks correct. And you want to try the choice activity and the objective quiz from here. So that is all for this unit. Go ahead and try those out, and good luck on your test.